I said earlier, quiet please, you're supposed to do some of the chapter review and to understand, to go way back when to check the extrema. Then I said your test is going to be made up of two parts. This is what part one is going to look like. I think I decided that I grabbed this out of the fall space Wednesday night in the Calc repository. So I thought, oh, that'd be a great practice test. So I'll send it. This is what they have as a practice test. And then on Monday, I'll go through what I wrote last year as a practice test. And then I'll merge them together to write the actual test. So with that said, are there any questions over 4.9, the review extra? I think I was going to take a grade too somehow today. Yeah. 21? All right.
We're going to do a 5% and check this.
All right, what are the directions for number 21? Find the extrema. All right. So f prime of x goes 1 times x squared plus 2x minus 8 minus x minus 3 times 2x plus 2 all over x squared plus 2x minus 8. So the first thing you normally do is take the derivative. It's on an open interval. There's no a or b to check. If there is an a or b or closed interval, remember, you have to find the function values of those also when you're looking for extrema. But since these aren't on an open interval, then you don't have to worry about it. On a rational algebraic function, though, you have to always worry about the domain. What is the domain of the function I'm given? X can't equal what? X can't equal, well, it goes x plus 4 and x minus 2, doesn't it? So it can't equal 2 or negative 4. So in place of the a and the b, you have 2 and negative 4. Betsy? Yeah, it's squared. So now, all I do is basically worry about the numerator because I've already addressed the denominator and set it equal to 0. Let me tidy things up just a little bit first. X squared plus 2x minus 8 minus 2. Uh-oh. Crashed? Yeah, it did. Interesting. That's okay. If not, I'll go old school. I can do that. I'll just shift to red. Put that right there. 2x squared plus 2x minus 6 minus 4x minus 6 all over the denominator squared. I don't feel like rewriting it. That's not going to yield any solutions anyway. I've already used it for the domain. So set the numerator equals 0. 0 equals x squared minus 2x squared is negative x squared. 2x plus 4x is 6x. Negative 8 plus 6 is minus 2. I think I'm going to go quadratic on this, don't you think? Now, this is the derivative. I mean, it's still over the denominator squared. So, if I go to quadratic, what are the solutions that are yielded? Negative what? And 0 point what? 35. Okay, so those are my critical numbers. Negative 0.35?
I did negative for you. I got positive for both of them. It's not negative. They're both positive.
All right. Now I got to flip them. Okay. I do, but obviously it's not going to come back the way I like, so I'll just have to make do. All right, so what do you get from the quadratic? Negative 1, 6, and negative 2. What do you get?
You get 5, 5, 5,
1.35 and 5 point what? Okay. So, along on that number line is also any restrictions in your domain. We said x could not equal what? Negative 4 and 2. Those also go on there because the graph can change, increasing and decreasing those points, negative 4 and 2. Now I pick test points, check for increasing or decreasing. If I put in a 0, it's going to come out to be positive, so that's increasing. Let's see, if I put in a 1, negative 1 plus 6 minus 2 is going to be positive also. If I put in a 4, negative 16 minus 2 is negative 18 plus 24. That's also positive. If I put in a 10, negative 100 plus 60 is negative 40 minus 2, negative 40. I don't have to check the denominator. It's always going to be positive because you're squaring it. Yep.
So we plug those things back to the derivative?
Yeah, I'm checking. Remember, the derivative is positive. If the derivative is positive, that implies that the function is increasing. And if the derivative is negative, that implies the function is decreasing. The slope of the tangent line is positive and negative. If I put in negative 10, I'll still get a negative number, so it's going down. So it looks like here, at these points, I'll have a minimum. Nothing along there. I'll have a maximum right here. To finish the problem off, you need to find the function values. But negative 4 isn't in the domain, is it? No. So that's out. So it must be an asymptote running right there. So the function is just going down on one side and up next to it. So that's out. So it looks like 5.65 is the only thing I need to worry about. Well, 2 doesn't have a function increasing or decreasing on both sides. It's only got increasing. For it to be a maximum or minimum, it has to have both arrows, up and down, on either side, and then it works. Okay? Great! How's the practice test look? In just a minute, how's the practice test look? Yeah.
I haven't, but
I don't have any of the solutions done yet.
well, we can just do it in class.
We're not doing brain break yet. I need to,
Can we start on this?
well, I'll do a few of these. We'll do a brain break, and then we'll go from there. But I want to make sure I get, not necessarily do the answers, but talk about how to do them. I haven't done these questions yet. Like I said, I just picked this up Wednesday, so.
Will we be turning this in sometime?
I don't think we'll be turning it in. I think we'll just use it to study because I like the idea of a true-false, getting after the definitions. If f is increasing on the interval from a to b, if f is increasing on the interval, f of x is increasing, from a to b. All right? And f is differentiable on a to b, then the derivative is positive, positive. That would be true. Nice, I like that. All right. If a function is continuous on a, b, and the function has an absolute minimum on that interval. Well, I don't think it has to have a minimum. Yeah, because it could be a constant. Right, that would be considered a maximum and a minimum. I don't know. I'll have to check on that.
Because it can be a regional, it can be absolute.
On a closed interval, if the function is continuous, I'll have to check the wording. I'm not sure if the continuous or the constant function, if it counts for both. I think we said it counted for both. Yeah.
If it's local,
Well, this says taking the local out. This is only absolute on a closed interval.
So if you don't know it, we should try.
Oh, raise yourself above. Get the most. The critical values on the function. What are critical values? Is it true? Yes. All right. So 4x cubed minus 16x. Oh, because I think we said even on a constant function, the minimum count as a maximum, they're both the same. So I remember talking about it over on that board. I'll have to check my notes, but I think it can be both if it's a constant function. So it would match the definition of an absolute minimum.
So then what about if it's,
Now, I think it says it almost word for word as one of the theorems. So check the theorem and then we'll talk about it. It's in the opening sections of the chapter. Set this equal to 0. You get the 4x, and then you have the x squared minus 4. So it looks like 0 plus or minus 2, doesn't it? So that would be true. Remember, the critical numbers just have to make it equal to 0. They don't have to give you an absolute minimum or absolute maximum. They just have to set the derivative equal to 0. What's the other thing a critical number can do besides 0 is undefined. Okay? This one's on a closed interval. Local minimum 0 to 2 pi. Oh, multiple choice. So I took the derivative. What does cosine of x equal a half at? Yeah, it's got a 3 in the denominator. 5 pi over 3, that works, doesn't it? And pi over 3 works. So 0, pi over 3, 5 pi over 3, and 2 pi. Now to check the minimum or maximum, you have to check the sign of your derivative. Is the derivative positive or negative? And that's the only way you can tell which is which. So I put in like pi over 4 into my derivative. Pi over 4. Yeah, 1/2 minus the square root of 2 over 2. I think that's going to be a negative, don't you? But wouldn't what? Well, no, that's in the fourth quadrant. Yeah. So I think right here it's going to be negative, so it's going to be going down. If I check a point between pi over 3 and 5 pi over 3, I could do pi. That'd be -1, wouldn't it, for the cosine? So 1/2 minus -1, positive, increasing. Oh, there's a minimum at pi over 3. So that'd be my answer. Just to double check, if I put in 11 pi over 6, that would be negative square root of 3 or positive square root of 3 over 2. That would be negative. So yeah, 5 pi over 3 gives you a maximum, and pi over 3 gives you a minimum. Nice. Mean value theorem, do you remember that? Sure, the mean value theorem. F of B, right.
Over B minus A.
Right, all over B minus A equals F prime of C. Right. So on this one, it says it has to be between 0 and 4. The derivative, 6x minus 12 equals, oh, we got to find the slope.
Why do we have to find the slope?
That's what this is. This is the slope right here. That's the average rate of change. So what's 4 squared 16 times 3, 48, minus 48? That's pretty nifty. That's 0 plus 11. So 11 minus, if I put in 0, 11, look a little bit like Lowell's theorem. 4 minus 0. So where does 6x minus 12 equal 0 at? Yeah, when x equals 2. I like that. Sure. Okay. All right, so far, Day one looks pretty easy, yep.
I can do it, Brad. Use this piece of chocolate or can I get
Go ahead and eat it. A package can be sent by parcel post if the sum of its height and girth, the perimeter of the base, is not more than 108 inches. Plus 2L plus 2W is not more than 108 inches. So it has to be less than or equal to 108. Find the dimensions of the box of the maximum volume that can be sent if the base is a square.
Why is it 2L and 2W?
Did it say the perimeter of the base?
Okay, the base is
Well, I just now found that out. I didn't know that. We can actually put 4S, can't we? H plus 4S less than or equal to 108. A package can be sent by parcel of some.
Wait, it's not a square.
I thought it says a square.
It does. It's the very last line.
Okay.
Base of the box is H.
All right. S, S, and H. Find the dimensions box of maximum volume. How do you find the volume? Right, length times width times height. So you're trying to maximize, in this case, the volume is what? S squared times H? Maximum volume. So H equals 108 minus 4S.
Why don't we just change to equals instead?
Well, because we're not really going to maximize or minimize this inequality. We're going to use it for a substitution, and the most, I think, would be 108 you would want. It can't be 109, but it can equal 108. And since we're trying to maximize something, I think we just pick the biggest one. Yes? The height? No, it's not. It's we changed these numbers to S's because it was a square. So this H is still the same as this H. Okay? So the height and the perimeter. Okay? So, now we have the volume equal to S squared times 108 minus 4S. 108 S squared minus 4S cubed. How do you maximize that? Derivative, right? So V equals 216S minus 12S squared. What? Yeah. So I set that equals 0 and solve, don't I? I'm running a little bit out of room there, but that's okay. Is 216 divisible by 12? What is it? 18? 18 minus S times 12S. Is this right? You don't think so?
Yeah,
I don't know. 0 is 18 and 1 6. Let's just.
18 and 0, isn't it?
No, it's 18 and 1 6. That's 0.
What's 216 divided by 12?
18. I just did it on the calculator.
Isn't this a true equation? 12S times 18 is...
Yes.
So it looks like the side is going to be 18, doesn't it? So S equals 18. It says find the dimensions. So 18 is the side.
I got 18 and 0.
4 times 18 is 72. 108 minus 72 is... You got a calculator, right? Okay. So H equals 36. S equals 18.
Wait, what did we do? We plugged 18
Back
in that.
into-
Right. There you go. Fantastic. That was fun. You can try that one again.
What's that sound like?
That's the answer.
Yeah, the dimensions, 36 tall and 18 by 18 on the base. Inches. All right. Number 7. You want to do one? Now, wait a minute. You're going to have to balance the brain break versus getting through this.
I'd rather do that.
We have 3 questions left.
Yeah,
Well-
one takes up the whole page.
Okay. Hey, I'm all about it because on Monday I got another one to get through.
No brain break.
No, a quick break.
We'll do a quick one. You can do it sitting down. You can do it sitting down. All right, stand up.
You should say something about Katie cheating on your mic.
No, that would be mean. I'm not about being mean. Ready? Take your, Mason, come up here. Take your thumb, left thumb, and hold it out to the side. And take your right pinky and match the direction.
Wait, a right angle?
Yeah.
The precise angle.
There we go. Has to be identical. Now, as quickly as you can, reflect it over the y-axis. Oh, that was good. I beat you. You got 3 out. You only supposed to have 2.
That is not the right angle.
He had this thing going, and he was doing this.
Sorry.
No. All right, now, ready? Go back to over the y-axis. Ah. You got me on that one.
Oh, you switched fingers.
Yeah.
My brain now.
3, 2, 1, go.
Wait. 1, 2, 3, go. Got it. Who won?
I've been there for a while already.
All right, now, ready? Rotate it this way. Now,
What's there like that?
now, you ready? Do the same thing. Got it.
Mason, you have 2 thumbs.
Wait, we got 2 thumbs. Thumb and pinky, thumb and pinky. One more time, ready? Oh, I had too many fingers go up. All right, good. They're broken. All right, cylindrical.
Can you give us the equation?
This is, oh, wait a minute. Gives you equations for what?
Like a cylinder?
I will, quiet please and listen very carefully to this. I don't want there to be any misunderstanding. This semester, I'll give you the equations if you need them. Next semester, I will not. Find dimensions of cylindrical juice. That's a bad cylinder. There we go, that's better. That utilize, now it says least amount of material. What do you think they're talking about? Surface area. When the volume of the can is 32 cubic inches, find either R or H only, not both. So you have to minimize the surface area. What is the volume of a cylinder? So 32 equals pi r squared h. And the surface area. It said of the whole can, right? So the surface area, I'm not sure, you check your textbooks for this, because the total surface area of a cylinder is 2 pi r h plus 2 pi r squared. That is the surface area of a cylinder. Plus the perimeter times the height, which in this case, circumference times the height plus twice the base. That is the surface area. So I'm not sure what equation they have in the front of your book. I've never really actually looked. Oh, they give you the lateral area. They give you the area around the side instead of top and the bottom with it. Okay. So, now which one do you want to solve for? H or R?
Or would it be easier to solve for?
Do you want to substitute H in this equation or R?
I'm going to set it equal to it.
Set this equal to H. All right. So h equals 32 divided by pi r squared. So far so good? A equals 2 pi r times 32. Oh, that's not so bad. Some things multiply out. So A equals, the pi's divide, 64 over R. Now to maximize or minimize this, obviously I'm going to take the derivative. So A prime, I'm going to go this way. Negative 64 over R squared plus 4 pi R. Now we're still maximizing and minimizing, so we're going to set equal to 0, aren't we? And I think I'll multiply everything by R squared. Just get rid of the denominator.
Where's negative 64 on our square?
Oh, I did the quotient rule really quick. 0 minus 64 times 1 all over R squared, the derivative. Okay. So I have negative 64 plus 4 pi R cubed. How am I doing my arithmetic, all right? So I take the 64 over, divided by 4 pi, that equals R cubed. That's, who?
So take the cube root of like the right side.
No, what's 64 divided by 4? 8? No, 16? Is it 16? So R would equal the cube root of 16 over pi. Okay?
Which is,
Yeah, you can leave your answer like that.
can we give you a decimal?
Sure, that's fine.
What did you get? I got one more.
There's a growing time.
Quiet. Now, we have 15 minutes. Do you want to try to do the next question, or do you want to try to do the last question together? Whatever we don't get done, I can do on Monday. All
Let's do both. That's how it works.
right, here we go. This,
Let's kind of work through this.
now, this format right here, quiet please. This format is how it is on your final exam. They give you a rational algebraic function with a bunch of questions, okay? Now the reason the test you have on Monday, that practice test on Monday, was written before I gave this final in May, and I gave this final again in the summer. So my practice test didn't have this type of question on it, so I'm glad you're seeing it now. Domain of the function, that's pretty easy. X can equal negative 2. So far, so good. Where is the function continuous? Negative infinity to negative 2. Union negative 2 to infinity, isn't it? Because x plus 2 is not in, yes they are, because they'll probably change it to a piecewise. X plus 2 is in the denominator. X can't equal negative 2, what? Sure, that's fine. X-intercepts, which one is that? Right. So X, so it's going to be, yeah, negative 5 and 4. Y-intercept, when you put in 0, you get out negative 10. So far, so good? Huh? Y-intercept?
0 and then the entire.
You are x equals 0? What are the equations of the horizontal and vertical asymptotes? X equals -2, you write as the vertical. Vertical asymptote at x equals -2. And remember the degree, there is an oblique.
Because it's 2/1.
Since it has horizontal, that's
Well, I think it's not, but I think just for the spirit of practice.
This is for.
We put it on the little.
OA.
Yeah, we can do a little.
Yeah, you can try it. Let's see.
What's the horizontal?
X plus 2, x squared, what was it, plus x?
Yeah,
Minus what? 20. It goes in there x times. That's not too difficult. Then -1. So there's actually an oblique asymptote at y equals x minus 1. Critical numbers, that's pretty easy, right? Take the derivative. F prime of x equals, trying to fit in this space isn't very fun. Minus x, well, I'm writing twice as big as you guys are, though. Yeah, 2x plus 1 times the denominator minus the numerator times 1, right? The denominator squared. Bottom one squared. X squared plus, I'm sorry, x squared plus x minus 20, all squared.
Wait.
Right, no, it's over x plus 2. Yeah, squared. Right. What is that noise? Is that in here or is that over there? The marble dropping. No, I hear it. It's somewhere not far from me. It's within 5 feet of me.
Maybe someone dropped the ball. I dropped it over here, but
Have you heard it?
I felt like it.
Okay, Landon's heard it. Have you heard it? All right, so it must be this way. All right.
I hear something wrong when you go to yell at him.
No, you're good. 2x squared plus 4x plus 1x is plus 5x plus 2. All right. Now we can do the quadratic here pretty quick. I'll sketch the graph someplace else.
We have to sketch the graph.
Well, that's part L, but I'll do it later. So that equals x squared plus 4x plus 22. Oh my gosh, what did you get for the critical numbers? They're all non-real? You got -2? Oh. Right, it's already an asymptote, so I wouldn't even have to worry about it.
So there's no critical
So
number?
there's no critical number?
That's a bad function. That's not very fun when that happens. Oh! Function increasing. So -2 comes from the domain. If I put in 0, it's positive. What's if I put in -10? It'd be 100 minus 40. So it'll be positive. So the function's always increasing.
So we just put always?
You can put it like this. On what interval is function increasing? -2. Huh?
What if we do put
Tuesday and Wednesday?
Do you hear me?
Is it Tuesday and Wednesday or Tuesday and Wednesday? Yeah.
We were working as much practice Thursday, Friday.
Monday. What? Yeah. If I don't do it today, I'll do it Monday.
Okay, let's move on.
Okay. Oh, I helped somebody with that. Who was that? Oh. Okay. Inflection points is double derivative, isn't it?
Yep.
All right, well, have fun with that. Let me know how it turns out.
What?
Oh, these three? Oh, okay. If those three are the same, then I'll go ahead and do it. The double derivative equals 2x plus 4. How many more space?
We have a lot of
It's not gonna matter because it's gonna end up it's gonna be negative. It'll be negative 36.
What?
Sounds good.
Yeah, but I concur with that. That's what my work. I appreciate your work. Oh, really?
Do you?
All right.
It took me a while, but I got it.
Hey, listen, I can factor 2 out of both. I can factor an x plus 2 out of both. X, tiny bit. So I'm factoring out a 2 and an x plus 2.
Oh my god. You can make those two there.
Whew, this is going to be fun. You guys having, yep. Right here.
How is
Yeah, that's be 2x plus 4.
2x plus 4 times x?
I took a 2 out of this one. I took a 2 out and an x plus 2 because I had it right here. Okay. If I take a 2 out, it leaves me with that, and take an x plus 2 out, it leaves me with that.
It's almost 206.
X squared.
I'm ready to go.
I'm on trying to finish, so Jake has something to do. Sure he will. Yeah, he will.
I bet you $1 million.
Hey, look at this. The x squareds go away. The 4x goes away. The 4 minus the... What number is that? 2? Minus 22. 4 minus 22 is? Negative 18.
What number is that?
I don't know. Negative 2 is the only place. If I put it in 0, it's going to be negative, concave down. If I put it in negative 5, it's going to be concave up. Interesting. So concavity changes. How's that possible? The function is always increasing.
So what are the points of
There aren't any points of inflection. This came from the restriction on the domain. Yeah.
So really you train that.
Right. You're at no points of inflection.
There's no critical
Well,
there's no
yeah, but this is setting you up because you see this question on your exam, then they change it for the final. And all these have different solutions.
Okay, so this part, this is the second part, because it asks on what intervals is the function concave up.
Yeah, negative infinity, negative 2. And negative 2 to infinity.
So it's on what interval?
Concave up, concave down.
Are you going to sketch the graph real quick, or
Yeah. Yep. Second derivative.
let's sketch the graph real quick.
Okay. Yeah? What's wrong? Oh, I got Monday to do that. Okay. It was x squared. What is it? Plus x minus 20.
Over x plus 2.
Hey, Mr. Manager, should say something.
So just use your hill, and we'll know.
All right, increasing, concave up. Oh, concave down a little bit. Yeah, I see.
So we can just draw that.
Yeah. Sure, that's all you have to draw on this one. Oh, it takes us a minute to sketch it. Nice. What?
Say something so we know that.
No. Jake, if you hear this, what's the capital of South Dakota? There.